Hey everybody, this is Patrick. At the time of recording, it is January 19, 2024. So let me welcome you to this new year, and I wish you all the best for your success, whatever you're trying to do this year. I've decided to continue the video series, and in expression 10, having gone through the basics of all the waves and how to control them, their speed, their magnitude, and the phase, I think that I would take the time to explore the interplay between multiple waves. These are the things that I think I want to cover in this video, so let's get to it. Combining waves, once you have two waves, they can affect each other in various ways. So let's find out how. To start off, very simply, we will have a cube again. Make it go along the x-axis. Have a sine wave in the y-axis, as we usually do. And let's make x go 1 unit for every 1 second. So expressions, we're already at translate x, and the shortcut is tx. So tx is equals to time, and create. And because we are 24 frames per second, when it reaches 24, it will be 1.0, and the box would have moved 1 unit. Okay. I'm doing this so that we don't run out of horizontal screen space. It will never reach 0 because our first frame is 1. So if my first frame was 0, when we are at frame 0, we would have 0. Okay? I think this box is too big, right? So let's change it to 0.1. So it travels, even for 1 unit, we give it plenty room to move and to see the amplitude. So very quickly, expressions on y is equals to sine, right, time again, and let's see what we get. So I keep wanting to do an uppercase on time, but it's just lowercase. Click create, and you get oh, that looks like it's just 1/8. It's not at the peak yet. Let's speed up the frequency, and we always want to see our graph editor. So let's have a look and evaluate, show results. So then we'll be able to see the function, right? If you don't want to see the linearly increasing x horizontal axis, we can just select and hit A key to frame all. So then we will see the curve that is the result in time. What we would do now is to have two curves. We are going to explore adding, do the adding one. We will have 3 cubes. 2 cubes having 2 different waves, and the third cube is the addition, so it's easy to see. Go back to frame 0 and duplicate, and the second cube, and then duplicate again. So -2. -1, just to be very precise here. We don't need to be, but visually it's just snapping to the grid, which is nice. What we can do is to, just do that again. Tx is equals to, right? Create. So they move together horizontally. Then ty is equals to, I can put them together. So ty is equals to sine time. That's some of the things that we talked about before. Expression node is targeting 2 different attributes, and they are both being driven by a single expression, and that's fine. On the first one, we had 2 expressions. When I go over here, you will see that this is named expression 1, and it only has 1 line, and it targets translate x. The second one, you see that it's expression 2, and it targets translate y. So I could make them the same also. Copy and delete. The expression is gone. Load back expression x here. You'll see that this is expression 1 again, and I can add this second line here and edit. You'll see the movement is exactly the same as from before, less 1 node. While there are benefits for keeping them separate, I don't think there is a lot of overhead. Having 2 nodes I feel would definitely be more expensive to calculate. An edit expression node is another entity. Maya has to keep track of them. Yeah, let's just keep it that way for now. For the third one, of course, we want to also drive x with tx time. So that's the horizontal moving amount, which is the same. But now, for the y, we want an addition of these 2 nodes. ty is equals to p cube 1 dot ty, right? So the translate y of p cube 1 plus p cube 2 dot ty, which is the translate y of p cube 2. So if I hit edit, you will see that it's adding. And now if we go back to our graphs, and if we graph p cube 1, p cube 2, and p cube 3, we just look at the translate y of each. I'm using the scaling shift alternate and right mouse drag. Look at the first y, the y of p cube 1 and the y of p cube 2, they're exactly the same. And now when I highlight p cube 3, you will see that it's double. So here is the 1.0, right, which is p cube 1 and p cube 2. And then p cube 3, because it adds both together, it becomes 2.0. And at any point in time in the graph, we have a doubling. What happens when it goes into negative? So when it goes negative over here, it's -1. It adds, right? It's still adding because our expression says so. So it adds another -1 on the second cube, right? So when you add a negative number, you actually subtract, so you get a subtract. So all the values south of 0, which is in the negative domain, they all add negative numbers. That's why they will remain negative. So what we get is a kind of accentuating of and reinforcing of the values of the curve. So that's adding. And now let's go to one of the cubes, like 1 and 2, right? Let's go into p cube 2, translate y. What happens if we now don't do the exact same value? Okay, so I'm going to times 0.5. So that's half, right? And hit edit. You will see 1 and 2, right? So the p cube 1 is, hold on, right? P cube 1 is our original, and it hits 1, and p cube 2, it's 0.5, it's half, right? And when they add, so 1 and 2, and when they add it together, you will see 1.5, 1.5. So it's 1 plus 0.5 is 1.5. Okay, it's not very fun when we keep going inside and change the values and evaluate. Okay, so let's expose that in an attribute so that we can change it more interactively. So we're going to go to p cube 2 and go to add attribute. We're going to add an attribute called, right, magnitude. Add that. We've got frequency, add that, and offset. Okay, so these three things are our basic components that we can change our sine wave by, which we have covered in the previous videos. So let's do the same thing in p cube 3 as well. So magnitude, frequency, and offset. So magnitude, add, frequency, add, offset, add. So now we go to the first one. I think I'm adding that on the wrong place, so that's cube 3. So going to undo that. I'm sorry. So add, right, magnitude, frequency, and offset. Now, because these attributes belong to the same object, I don't need to explicitly name the object again. So this time has a frequency, right? So times frequency, okay, times magnitude. And there's an offset. So offset plus time. Then you can times frequency. Right, so let's edit, and you will see the curve 1 y has flatlined because our magnitude is times 0. So let's interactively change that. What I did was click on the attribute, go to an empty area and middle mouse, and you'll see that you'll be able to scrub and change the value as we like. So 1. So this whole thing times frequency. Everything times 0 is 0. That's why we still don't have a response from the curve. So let's put it to 1 also. And Okay, so frequency was 0. It doesn't update here. Oh, frequency 0, and when we move, everything is 0. But when you do a frequency of 1, it goes back to 1. Okay, so the good thing about exposing your values here is you can keyframe. Okay, so you can keyframe no strength from the magnitude, and then you can key it up. So that's where manual keyframe and manual control directability comes and meet our mathematically created things. We can combine them together if we wanted to. Okay, this graph is not in real time, as we have found out. The most accurate thing to see is from the viewport. So this is our new expression. We're going to update that for cube 2 as well. You remember that because of this default object, it mentions itself. So if I exclude all the pcube1, it means that it's assumed to be referring to its own attribute. Okay, so with this, right, I can copy this. If I also exclude pcube1, right, when I evaluate this, it means that pcube1's translate y, pcube1's offset, and pcube1's frequency, and pcube1's magnitude. This is what I do when I want to copy an expression to many objects. I take away the pcube1, then I Control C. Right? If I do this and evaluate, you will see that the pcube1 comes back because it's doing it to its local object, that is pcube1. So same thing, if I go to pcube2 and load the translate y, you'll see this, and then I can take this away and Control V and paste. When I hit edit, you will see that everything becomes pcube2. That's because the current object now is pcube2 and the expression belongs to pcube2. That is just a recap. Probably you already know this from the previous videos. These two, they don't have the same value because pcube2 is now flatlined because everything is 0, right? So if we put 1, 1, and you would see that the pcube2y, if we click away and click again, it probably updates. If I do a magnitude of 2, right, it doesn't update, but click away and click it again, and it now goes to draw from positive 2 to negative 2. 1 and 2, and then if I now select pcube3, you will see the highest 1 plus 2 is equals to 3. In every frame, the addition is adding and resulting in pcube3's value. So now let's keep them the same. That's what we want to do in the first place. So pcube1 and 2, and change both. They have the same attribute, so when you change, both get the change. We have seen that 1 and 2, and then the 3 is the result of 1 and 2. What happens if the magnitude of 2 now becomes a negative 1? That means when the curve goes up, because of pcube2 being negative, it starts to go down. So let's try that. So negative 1. Let's redraw the curve. Right, it goes down first, then goes up. Right, I'm going to select pcube1 and pcube2. So pcube1 is the white one, and pcube2 is the green outline. And you can see both exactly opposites of each other, and when they come back to meet 0 in value, they meet at the same time. Okay, so that gives us kind of a helix or a fish or an eye pattern. They both are exact opposites of each other. So it's still adding, right? And for those with the sharp observation, you can see in the third cube in the background is actually flatlined. To me, that's very fascinating. When they both have the same, they double up, right? Because they're adding to each other. But this is cancellation. So what happens when 1, 2, and then I'm selecting 3, and we all select the Y transform, you'll see that the third cube is absolutely flat. We've already mentioned that, right? For the same magnitude that's going up into positive, we add a negative, so we minus back, and we subtracted it back to 0. And when this goes into negative, or let's say it's negative 2, this guy negative 1, right? This guy negative 1, and we add the second cube, which is positive 1, we bring it back up to 0. So let's go back to our notes here. So we know that it reinforce. If a doubling occurs when two values are of the same value, and cancellation, they cancel each other out, which results in 0. For that to happen, right, the two values need to be the same opposite of each other. When you add back and add negative, one is a negative value and you add a positive, or the other way around. we can also multiply them. So this scenario that results in the third being flat needs a few things to happen. It requires the two waves to be perfectly out of phase with each other. When we say out of phase, is when this guy is positive, this guy is negative. When this guy is negative, the other guy is positive. I'm going to put back to 1, so we get doubling. So we graph editor, you get, and then when the third graph comes out, the cube 3 is the doubling. Now I'm going to increase the frequency to double. Let's keep cube 1 at the default, and then now let's change cube 2 frequency to 2. Let's see what happens. Okay, so I'm going to deselect and select it again. So cube 1 is like that. Cube 2 is doing 2 oscillations when there was just 1. Now we have 2 different waves traveling at 2 different speeds, and when we add, right, it's adding different things. And it's not in sync with each other anymore. So when I go to cube 3, I'm just going to hide 1 or 2. Can you see that it's kind of repeating? It's kind of repeating, but it is not a recognizable sine wave or a cosine wave anymore. Okay, so let's see what that looks like. I'm going to hide these 2. Right. So of course we can, if we really want to see what this is doing, right, we can go to animation and visualize and create an editable motion trail, and with the default ones, with the default settings, reset, create motion trail, you'll be able to see the trail of this. Okay, and what's gone before will become red, and then what's going after will become blue, will still remain as blue. So that's mirroring one cycle. I think one cycle would be from 0 point to the 0 point, right? So one cycle and one peak, like that. So one cycle and one peak. Okay, so that's interesting because we've broken free of our sine pattern that we're so familiar with, right? You can tell it miles away, and oh, that's a sine wave. If you see any object in the scene oscillating left and right, immediately you can tell that it's sine wave. But if you see something like that, right, if it's driving rotation, you may not be able to tell what it is. Okay, and that is the result of us increasing the frequency of cube 2 to 2. What happens if it's 1.5? Unlike the graph editor, right, here you can actually see it move and update, which is really, I'm really thankful for this. Okay, so if we set it back to 1, you see that doubling, right? When the cubes move halfway, this is double. So if we set the frequency to 1.5, okay, we're gonna do it in multiples. Okay, so this. If I put the frequency to 4, right? It's kind of 4 times for every 1 oscillation in the first curve, right? So, and you'll see, let's hide 1, 2, and hide the motion trail. You'll see it go in an interesting pattern, right? You get to see like small, big amplitude, and lowering overall, small, and then large amplitude, right? So that's, again, that's interesting. These are things that we can do with 2 curves combined. This kind of well, you can do like Flappy Birds, right? Birds in flight, unstable or something. Okay, you'll think of something, right? This is just to enable what we can create and to free your creativity. What happens if I keep increasing that? If I increase frequency to 8 or 12? Hide that just to see cube 3 by itself. Right, so it's just playing around and trying to understand what these curves are doing. When you see the trajectory now, you actually get to see a huge sine wave, right? What's actually happening is the curve 1, right, is the huge sine wave, within our timeline, right, we just see two peaks, and here you'll see two peaks. So that's the sine wave from cube 1. And then the second cube is doing the high frequency thing, right? So then this is giving you that high frequency thing, but it's riding on top of that low frequency. That's because we added them together. So that's the we call modulation. The p cube 2 is modulating the wave from p cube 1. So if we want to see that even more and get another kind of animation, another look, I'm going to drop this magnitude to 0.2. p cube 1 is kind of the dominant one, and what's happening here would be it's 1.0 adding and subtracting from that value of the original curve, plus minus, and adding a little bit and minusing a bit in the positive direction and in the negative direction. Hence we have this kind of pattern. Okay, you can do a lot of things. It's just understanding what's going on. I can control the main thing, right, the main wave that has the larger magnitude, and then using a smaller magnitude, I'm kind of disturbing the value of that large magnitude. Coming back, these are very observable. You can see two patterns going on straight away. So the more interesting one would be not to do multiples of 2. So the frequency of kind of times 2, times 4, times 8. So if I do 3, right? So if I do like 4, okay, I'll do 8. Right, it's still visible, right? What about 6? The frequency of the second curve, right? 6. Maybe not. You still can see some kind of. You still can recognize two peaks and all that. But if you do like 5, right? You can see the peak, and then you can see another smaller peak on both sides. So if you do like 4 or 3, it's not in multiples of. So if the first curve, for every one time it does the oscillation, the second curve also finish 2 times, they will still end up at the same place, if you get what I mean. I'm going to get the second cube and do a multiple of 1, okay? So let's see where they intersect each other. Y and Y. You'll see where they intersect at 0. Right? This guy goes up and down and back. Right? So that's one oscillation. And then the second cube is up, down, up, right? So that's 2 oscillations, and they end up at the same place. They meet each other at 0. So kind of a reset point, isn't it? Then you go one up, down, and back up. You got up, down, up, right? So that's 2. So if I do 4 now, right, you'll see that every time it intersects 0, you got 2, right? That's kind of multiple of 2, right? And it goes back up, and another 2 peaks has passed, and then they meet at 0 again. And this makes for very predictable, very repeated patterns that you probably the eye can track. Okay, now let's observe if it is not in the multiple of 2. So let's say 3.56 or something. Right now, when we observe the curve, it will not be so easy to have a. Let's just mess it up a little bit and select the 2 again. Okay, so they all start off at 0, right? Because we don't have any offsets on both. So at 0, everybody crosses the 0 line, and then you can see that after one peak, right, reaches 0, the second curve is nowhere near 0. Okay, so not meeting each other. And then when you go back up to the next 0 point, you can see that the curve is almost reaching 0, but it's not, because it's kind of the frequency is kind of 3.56. Is a very strange value, right? And then after 2 peaks, it comes back to 0 again. Again, it is not meeting at 0. So kind of the curve doesn't reset, and it doesn't meet each other at a predictable point. So when do they meet each other? I think at some point they might meet each other, but then because they are kind of moving at their own timeline, right? Because the frequency is different, they will meet at 0. You can't really tell. Okay, so I'm looking at where each of the curve meets 0. That's close enough, but not really. Here it meets 0, 0. They miss each other. Here, almost, but they didn't. Okay, so you'll never see them repeat, so to speak. Okay, and we're not doing science experiments here. We're doing visual stuff. So as long as you don't see a repeated pattern that comes back upon itself, we should be happy. Let's say 200 frames is what's needed in my animation for this shot, right? It's 200 frames, kind of almost 10 seconds, pretty long. And let's say if the pattern does repeat itself, like even one time over here, right? I'm still safe because I don't see enough repetitions to recognize, say, hey, that's an expression. Hey, that's a mathematical thing. Math is boring, or expressions generated curves are boring. It is not. As a rule of thumb, don't do multiples of each other. So if one of the curves frequency is like 3, the second curve don't do 6, don't do like 5.4 something, or do 3.8 something. Okay, so don't do multiples. That's one thing. Okay, then the other thing is, if we increase our frequency enough, you will see repeated even on the second curve, right? The second curve modulates the first curve. It's easy to spot when the frequency is enough. And if the frequency goes, let's say 6, okay, I can still see it, but one is a weaker magnitude, the other one is a stronger magnitude. What I was trying to show is now I'm in kind of a neutral territory where almost broken up the pattern, but not. This is the second point I want to make on how to break this pattern so that it's not very detectable and noticeable, right? My magnitude was 0.2, which is very clearly the weaker wave that modulates the primary, right? This was intentional so that we can see. If now my magnitude is 1, they are kind of equal standing in terms of strength, right? So, and then if I further drop the frequency, it would be even harder to detect. These two things, frequency and offset. The offset, we observe that no matter the frequency, when everything starts off at 0, they're meeting each other here. What we can do also is to have a curve 2 offset. What are we doing? We're actually shifting the whole curve horizontally in time, because the offset is kind of time plus something. Swimming and sliding across each other when we have two waves. So again, they are of equal magnitude. It's quite hard to see. So I'm going to grab the second curve's magnitude to 0.2 again, and we're going to increase that frequency to something that we can spot again. When you're building a curve like that and you're kind of building motion, you want to start with something that your eye can pick up. And once you can pick it up, then now we kind of mess it up. Or else you'll be going around in circles trying to randomly throw in numbers and you wonder why it doesn't work. It's just faster like that, okay? So repeat enough times so you can see, and then gradually reduce it to mess up, okay? Now that we can see the first curve and the second curve, if I go to cube 1 and I offset, right, you'll see that the second curve, all the peaks, right, are not moving from where they are. Right, they're just kind of subtracting from the main curve, but where they are in time remains the same, right? And then now, if I go to the second one and I offset, okay, you'll see that, hey, that's an interesting effect, isn't it? Because we offset the time where it happens, it's independent of the first curve, but because it's adding and subtracting from the first curve, you will see that the huge low frequency curvature remains, and the second one, they slide along each other and swim across each other. Then now, because of the offset, when I select both curves, you'll see that on frame 0, they don't both start off at the same time. And they both start off at the same time is when they next meet with each other at 0, which is not going to happen anytime soon. I like that fact that I have control like that. You have to understand the curve and the components and the factors that make the curve do what it does. And then you can have some fun. Okay, so on the second one, we're going to reduce that frequency. And don't forget, we can we can keyframe these now because they are attributes. Don't be mistaken. I mean, because I'm so used to, I'm seeing this visualization of this graph, right? But when I hide it, is the actual motion of the cube. Okay, so this should be the motion of the cube. When I keyframe this, it doesn't change the graph will look very different. We're not changing the curves. It feels like a modeling thing, right? When we saw the graph, but this is what we will be seeing on the cube. Okay, so let's bring the graph back again. So we can at some point like keyframe it so that the offset kind of goes faster, and then you'll see that the cube kind of, even at the same point, right, in the dominant main curve, it can still go up and down pretty fast. So we can make time pass faster if we keyframe these. Okay, so can we use these things and make the box, which is box number 3? Yeah, make the resulting box like have some kind of high frequency turbulent and then kind of calm down at the second part of the journey. Let's try. Okay. To make the box have turbulent up and down, right, we know that we need to increase the frequency of one of these. Okay, so let's try and increase the frequency to a high number. Like we said, right, because our frames are limited, looks like our divisions are limited. If I keep going up, the curve is very fine. It goes in between the frames. We do not have enough frames and resolution to display the peaks. So we get these things like that. Okay, not what we want. So probably kind of 20. Yeah, so let's try like 18. Okay, so I'm going to key like, so it's going to do this turbulent thing for maybe 36 frames, for example. Okay, 40 frames. Okay, so I'm going to keyframe this. And then it slows down. So I'm going to, from 40 to 80, I'm going to key it to a frequency of 3. Okay, so what happens then? So if I go back, you can see, so I'm selecting, no, we should select cube 3, okay? Very confusing, isn't it? But you see that this green one with the green outline, whatever we selected, up, down, and then it goes, right? It goes into a smooth one. Yeah, so let's update this curve. This trail is not updating because of our keyframes. It didn't update. We can put 0, 1. Just change something and then see whether we can force it to regenerate. So start time 1, 0. Right. So changing the start end time, you get the result of our keying. And I'm gonna hide these two and then get our cube. Right, and then it goes into whatever we just did. We decrease the frequency from hectic to a lower frequency, so we get this. Of course, we can change our tangents and for a smoother transition. Hide those again. Hide those. Hide the curve. The trajectory. Right. And I don't think anybody will be able to see that these two are actually made up of lots of sine curves. They're all made of sine curves. Like we said, sine curve and cosine curves are the same. On top of that, if we really, really want to break that look, there's nothing to stop us from adding a noise curve to it. Okay, so you can add another noise time times 4 or 5 times 0.2. So a very, very small amount of noise. Okay, so you'll know that the multiplication will evaluate first and then it will get added to. So that's currently the Y value of this. And then now I'm going to hit edit and we'll see it update. Right? You get additional, so undo, redo. So another thing that I might want to do, right, because to see before and after, I have to undo and redo. So what I can do now is just keep this, okay, and then add one more. Y is equals plus equals. So I might not have mentioned this. Plus equals means the current value of Y. So here, at this point, we already have that curve, right? And then I have one more line that updates again the value of Y, means taking the current value and add another noise of this magnitude and frequency to it. So it's exactly the same as adding to this, but when we're doing it in two lines, I'll show you the benefits. So edit, right? So that is the noise modulated on top of everything. And what we can do if we want to see the one without the additional noise, I can do this. So this is the remark, and this line will never get evaluated. So when I hit edit, can you see that? So hit edit, the noise comes back again. Here we can take away the noise, right? So as an additional feature of that, we can now go and create one more attribute, right? Since we can add it in and take it out, what we can do is to do the additional, right, add noise, whatever. So it's an additional noise, hit add, so we created another attribute, and then we get, it's called add noise. So times, instead of times 02, we can times add noise. Okay, hit edit. Now we can do this. That's just refreshing the curve. It's plus 1.7. So if we do 0, okay, we're going to bring back this just to see. Okay, so that's 0. It added nothing, right? Because this add noise now is at 0, it times 0. So it takes the current value of Y and add 0, because this value is to 0 because of that, right? It adds nothing. But now, when I add the noise, you'll see it's an additional layer of noise that we can go into negative, we can multiply, and we can keyframe. Now we have one type of noise, which is the second p cube 2, right? The high frequency of p cube 2. We go back into a lesser frequency, and then at this point, maybe from 90 onwards, right, I want the other noise to kick in, right? So I can keyframe 90 to 100, and I introduce that 0.3. Okay, and to get that to update whatever we see, go back to motion trail, change the time to 1, then change the time back to 0, and then you get an update, right? And from here to here, the noise is actually fading in gradually, right? So we don't have so from 0 to 0.3, and then that kicks in, and the huge curve is still coming from p cube 1, right? So we got two different kinds of noise, but then who's to say that we can't just add like 5 different layers of noise, or you can subtract from each other, or you can multiply to each other, right? So I hope you see the possibility and the potential from this. Before I go and we end this video, I want to point out to something, right? You see that the keyframe of frequency, right, is 17. And when I start reducing the frequency, right, I expect to see the peaks get more and more spaced out, right? But why did we have spikes like that, right? So like before it spaced out, it went through very, very high frequency, not what we expected, right? It was not what we expected. Then before it goes into before our noise take over, before it goes into a evened out low frequency area. Why did that happen? I think I don't think I can sufficiently explain that to you right now, because this isn't part of my whatever I wanted to say, but because it went through all the other okay, this is the same problem when I wanted to use an incrementing value to drive a wheel that turns forward. And then when I want my wheel to slow down, I encounter that it spins backwards. Okay, so this is the thing. When the frequency goes down, the value swims through the frequency to drop down to a lower frequency. I think the sine value kind of is evaluating backwards from 17 to so it goes through a cycle of like 16, 15, which is still high frequency, but then because that frequency is going backwards and going down, it goes back through the values before it reaches the frequency of 2. I know I'm listening to myself and it doesn't sound good, and it's not sufficient to explain this. In the future, I actually want to do a wheel turning video, and maybe we'll be able to see what it is. For you guys, brilliant guys, I know who happen to be chancing on this video, and this is just a challenge for you. See whether you can sufficiently explain it to the rest of us why this is happening. Okay, so whatever I just said was my insufficient attempt, and let that be a hint to you. If you can get at what I was trying to say, please, in your own words, put it in the comment, and I will be so grateful and that you're helping out in this channel. I am thinking of setting out a Patreon page. When I do, I will put a link there. If you want to buy me tea, buy me coffee, whatever you can, please. Just support me. I don't think, judging by my update history, I don't think I can commit to X number of videos a few months, or even that kind of frequency and constancy. But I'm really, really grateful for people who stick with me and who are supporting me and who are discovering these videos to be useful. I hope to continue to do videos with insights, so that we can all learn together. Okay, so I've left out. No, I haven't. Pushing forward the motion by a combination of waves. Pushing forward motion. Yeah, I don't know what I'm writing this about, but we've sufficiently showed that the waves can slide along each other, which is interesting. So there are a lot of, and I didn't say about this multiplication, but I think just reading on it, you probably will know what I'm talking about. For those of you who have followed my video and have understood what normalized values and inverting the polarity would be. So thank you so much for following me. I hope to be producing more videos for you, and I will see you soon. Goodbye. Have a good 2024.